Welcome to PM Ready, your guide to becoming PMP certified. This is the lesson on Quality Tools, Part 1. This lesson covers several common and useful tools that are used in a variety of circumstances, but particularly in quality management. Although they're useful for both analyzing and displaying information, the PMBOK guide categorizes them as data representation tools. Speaking of which, the PMBOK guide used to provide more information about these tools, but that doesn't make them any less valuable on your projects. And you should still expect to see some of these on the PMP exam. A lot of the details of project management that you'll need on your project, as well as for the exam, are beyond the scope of the PMBOK guide, which is why these details are included here. The objectives of this lesson are to teach you what you need to know, so that, number one, given an example of a quality tool, you should be able to identify which tool it is, state its purpose, what it's useful for, and be able to interpret the information presented by the tool. And number two, given a specific circumstance or need, you should be able to select the best of these quality tools to address that need. The 7 basic quality tools were championed by Isokawa, who was the father of quality circles, and who was influenced by the contributions of W. Edwards Deming in post-war Japan. These quality tools are less intimidating than statistical process control and are a complement to it and can be used effectively with little or no expertise in statistics. These 7 basic quality tools are the Isokawa Diagram, also known as the fishbone diagram, or as the PMBOK guide calls it, a cause and effect diagram. Check sheets, control charts, histograms, Pareto charts, scatter diagrams, and stratification. Later, in 1976, the Union of Japanese Scientists and Engineers came up with a new set of 7 quality tools. These are known as the 7 new quality tools, or the 7 management and planning tools, or sometimes simply the 7 management tools. They are affinity diagrams, relations diagrams, tree diagrams, matrix diagrams, matrix data analysis, arrow diagrams, and process decision program charts. This lesson includes these as well as other useful quality and management tools. These tools are presented not in the order in which they were introduced, but roughly in the order of complexity, with the simplest ones first and the most complex ones later. We start off with checklists. I told you we'd start with the simplest ones first. A checklist is simply a list of things to do or to check. It can be as simple as a to-do list, or it can be a list of process steps to follow, or a list of attributes to check for, or even something as critical as a pre-flight checklist. Checklists may be simple, but they are deceptively simple. They're so effective that they're regularly used to ensure quality and safety in the most high risk of situations, such as airplane flight, space flight, and numerous high-risk jobs that risk life and limb. Next, we have check sheets. You may be thinking, hey, wait a minute, didn't we just cover those? And here's where the vocabulary can be a bit tricky. A check sheet is not the same thing as a check list. It may be helpful to think of check sheets as tally sheets. On a check sheet, you don't check things off, you count things, or tally them up. Check sheets can be used to gather information, such as when you're doing inspections. in which case you would use actual tally marks. You add a tally mark each time you observe or count something. For example, you might follow a checklist to know what to inspect, but then record the results on a check sheet by adding a tally mark for each item that passes inspection, and in other places on the sheet, adding a tally mark when different defects are found. In other cases, check sheets are used to display counts, such as in the example you see here. This check sheet shows the number of different types of defects found in a software development project, and which day of the week they are found. From this, you can see what types of defects are most common on your project. And you can confirm your suspicion that people make more mistakes on weekends than during the week, and that more mistakes are made on Mondays and Fridays than on other weekdays. This can help you know where to look for root causes that can be eliminated or mitigated in order to reduce the number of defects introduced. Check sheets are another example of a simple tool that can provide powerful insights. An affinity diagram sounds a lot more complex than it really is. In this context, the word affinity is used to mean similar or related. Lots of different ideas are used as input for an affinity diagram. These are then organized into categories. Usually the categories aren't defined ahead of time, though they could be. Usually you start off with a bunch of completely unorganized ideas and try to figure out which ones are similar to each other, or related, or naturally belong together. You just put those together in groups, and then figure out a good name for each group that best describes the items in that group. And that's where you get your groups or categories from. Affinity diagrams are used to help you organize items, such as ideas generated from a brainstorming session, to help you make sense of an apparently chaotic collection of information, and to understand issues that are otherwise too large or complex to grasp as an unorganized set. Issues that are complex because they have so many factors, variables, components, or interests, groups, features, or attributes. For example, you may start with a brainstorming session that generates ideas about the root cause of an issue or a problem, or features for a new software application, or ideas of new products or services to offer, or ideas for enhancement or new features to add to an existing product, new customer groups, stakeholder groups and their interests and concerns about your project, project risks, ideas of how to involve and engage stakeholders, or different ways to solve a problem. And it's not just useful for ideas and brainstorming, but also for all sorts of large data sets, such as all the comments from a survey, all the issues raised by customers or called into the call center, all the defects found in a system or in a production line, or all of the warranty issues. Laying all of these out and grouping them can help you organize your thoughts, your approach, or see patterns that lead you to solutions to problems, or help you to identify common root causes, or to know where to focus your efforts. Affinity diagrams can be used effectively in small teams, such as when brainstorming, but they can also be adapted to larger groups. You can separate into teams and have each team first brainstorm, and then have each team organize what they've come up with into affinity diagrams. You can then combine and compare the results of the different teams to come up with a unified set of items and categories. I've seen this done effectively with groups of up to 50 or so people, divided into teams of 5 or 6. A mind map is another tool that can be used both in the process of gathering or generating information, as well as to represent the results in an organized way. A mind map is a little more organized than an affinity diagram because it has multiple levels of relationships. However, like brainstorming or affinity diagrams, it starts with a main idea of some kind at the center. It could be anything really, a problem to be solved, a question to be answered, a stakeholder to engage, a risk to be managed, or whatever. Ideas or actions or tasks, or what have you, are then generated and organized into themes, groups, or categories. And then each of these ideas or whatever can have others connected to it. And this can go on for any number of levels. It allows for a more complex representation of relationships than you get with an affinity diagram, but in a relatively unstructured way that allows for quite a bit of flexibility, which is why a mind map is often used with brainstorming to organize ideas, either after initial brainstorming or actually while you're in the middle of brainstorming. Being able to quickly represent the relationships between ideas can help you to generate more ideas that are related or supportive. Next, we have the Isokawa diagram, also known as the fishbone diagram, because it's typically drawn in a way that makes it look something like fish bones. This is very much like a mind map, with a central concept, groups, or themes branching off of that main concept, and lots of things connected to those groups. However, an Isokawa diagram is called a cause and effect diagram because it has a more focused purpose and usage than a mind map. A cause and effect diagram, or Isokawa diagram, is used in root cause analysis to help you to trace undesirable effects back to root causes. It helps you to identify many possible causes and then sort these into categories. The procedure is that with an Isokawa diagram, you start with an effect, usually an undesirable effect, some sort of problem as the starting point or central item. This is drawn as the head of the fish. Different possible causes of this problem are then listed and organized by connecting them to one of a few different groups represented by large bones or branches in the fishbone diagram. A common traditional set of such groups is machine, man, method, and material, and each cause is connected to one of these, similar to grouping things in an affinity diagram or a mind map. Now, these don't have to be the group names. They can be anything that makes sense for your situation. And causes can have causes which have causes, and so on. For example, if the effect is arriving late to work, one cause could be getting up late, which in turn could have a cause of the alarm clock not working, which could have a cause of the battery dying. So you can see this can go on for any number of levels, connecting causes to causes. Tree diagrams are a familiar tool for representing increasing levels of detail of something. A work breakdown structure is one example, as are others introduced previously, such as resource breakdown structures, risk breakdown structures, organizational breakdown structures, organizational structures or org charts, project team structures, product breakdown structures, and so on. Perhaps the most universally recognized type of tree diagram is the org chart, which shows your organization's employees organized into different management layers, departments, teams, and so forth. A tree diagram is most often used to represent information that's been generated in some other way, such as starting with an affinity diagram or a mind map, or even an Isokawa or fishbone diagram. This information can then be placed into a nice, neat tree diagram for presentation. On the other hand, A tree diagram can also be used while generating information, such as when creating a work breakdown structure, which will often start off with the deliverables or phases, or even a complete work breakdown structure template from your organization or industry, which you'll then fill in with your project's scope, breaking each item down into levels of greater and greater detail. The result could be a WBS with the product at the top, deliverables or components at the next level, followed by planning packages and work packages. Later in your project planning, you then add the actions required for each work package as part of the define activities process. A tree diagram isn't limited to physical things. It can be used to display anything that has hierarchical relationships, such as starting with an objective or goal, and then breaking this down into intermediate goals, steps to reach them, and individual tasks or to-do items. A tree diagram can also be used as you would use a cause and effect or fishbone diagram to search for the root cause of a problem. Because a tree diagram is so easily and universally understood, it's one of the more common ways of representing hierarchical information and communicating details in a structured way. For example, a product breakdown structure or a bill of materials uses a tree diagram to show the hierarchical relationships of all the components of a product, organized into assemblies and subassemblies and individual parts. Here's a simple example of a tree diagram used to represent a product breakdown structure. It shows a computer as the top-level item, the product. The next level shows the main components of the computer, including the box that houses it, the monitor or screen, keyboard, mouse or trackpad, and I've added a few others, speakers or headphones, a microphone, and a camera, devices that are useful for meetings or recording webinars or podcasts. You can see that the box is further broken down into its component parts: the motherboard, the hard drive, some RAM, and the case that holds these components. The hard drive then has the operating system and applications shown at yet another level below that. This is just a simple example and certainly doesn't include all of the details, but it should give you the idea of how a tree diagram is used to represent a product breakdown structure. Next, we have a special type of tree diagram known as a process decision program chart. As you can see, it starts with a project or operation at the top, which you then break down into components, deliverables, or activities, or whatever makes sense for your project or operation. You continue to break this down into lower levels of detail, getting to work packages or tasks, or whatever level is necessary to allow you to most effectively identify and list the risks, what could go wrong, with each of these. For each risk, you then see if you can come up with one or more responses to manage the risk, and then you use X's and O's to mark which responses to implement. The Process Decision Program Chart is particularly useful when planning risk management. It's used to systematically identify what could go wrong, which is applicable to the project management planning processes of identify risks and plan quality management. In the case of a project, it's easiest and usually best to start with the framework of your project's work breakdown structure, including the activities that have been added to it by the define activities process. Then identify and add the risks to the bottom level of the WBS. Then you can brainstorm different risk responses and decide which of these to implement, and make the appropriate changes to your project management plan to include these risk responses. You can follow a similar process for identifying potential quality issues and coming up with preventive measures and quality control tools to use to address them. The Process Decision Program Chart is useful not only for helping you organize your thoughts during planning, but for communicating this information to stakeholders, and for reviewing your plans periodically. This is the end of Part 1. PM Ready is a publication of PM Guaranteed and is based on the Project Management Institute's PMBOK Guide.